Example 1, we did A, B, C, and D. Practice sketching and finding the measures of coterminal angles, both a positive and a negative coterminal angle. So then on example 2, we just want to sketch each angle and find the reference angle. So this is what we did earlier in the week that we're practicing. Okay, so 380 degrees until you really start. Oh no, my pen's not going to work today at all. It's super laggy. Oh, here we go. Good. All right, until we've been doing this a little bit longer and you've really got the hang of it, it may be helpful to you to write the angle measures on the axes. So remember, the initial side of an angle in standard form is always the positive side of the x-axis. This is our 0 degree. Okay, and if we're going in the positive direction, which this is a positive angle, this would be 90 degrees, 180, 270, and then full circle is 360. So we do one full rotation around, that's a full circle. Okay, so I want to know where 380 degrees would be. What quadrant would that put me in? Because it would be quadrant 1, because if I rotate all the way around 360, I still have to go how much more to get to 380? So it's going to be approximately here, and I would draw the arrow showing that I spiraled around and came back to it. So I went more than one full rotation. So that's my 380 degree angle. So that's the sketch. Remember I said before, the sketch is not just the terminal side. You can't just draw the terminal side and be done with it. You have to have this arrow drawn showing what direction you went in and how many times you spiraled around if you did have to spiral around. Does that make sense? Because with coterminal angles, I could have just gone straight there and stopped, or I could have gone in the negative direction to get there. I don't know what this angle is unless you have that arrow drawn. So when you're asked to sketch, make sure you have the terminal side and your arrow. So then they're asking for the reference angle. That's the from the terminal side to the nearest x-axis, whether that's the negative or the positive side. So in this case, that's right here. Okay, do y'all agree with that? So I'm going to label that. We'll still use alpha. So how big is alpha here? Yeah, you went 20 degrees past the full rotation. The size of that angle is 20 degrees. Remember, the alpha, the reference angle, is always positive, and it's always going to be 0 to 90 degrees. Okay, it won't be bigger than 90. All right, now this one is in the negative direction for B. So when I start here at 0, now this is negative 90, negative 180, and negative 270, and then negative 360. So real quick, before I even go on with this problem, what do you know then about 270 and negative 90? What's the relationship? What's that word? Coterminal. They're coterminal angles. If you were to draw out an angle at 270 or at negative 90, the terminal side would be here on the negative y-axis, right? So those are coterminal angles. They stop in the same place and they started in the same place, but they're different measures. Okay, all right, so we're going in the negative direction, so clockwise from the positive x-axis, and we want to go 415 degrees in that direction. So what quadrant am I going to stop in? Okay, because if I do a full rotation, that's 360. How far past 360 do I need to go? So 55. So maybe here-ish. It doesn't have to be perfect. We're not whipping out protractors or anything, just estimating. It does need to be in the right quadrant though. Okay, and it'd be a little more, it would be a little more than halfway, because halfway would be 45 degrees, right? I don't know if mine is that accurate, but it's good enough for now. Just make sure you're estimating relatively close. So that is negative 415 degrees. And then I want the reference angle, which in this example, again, happens to be how far past a full rotation did we go? And what did y'all say that was? 55 degrees. Because that was 415 minus 360. So far, so good? All right, negative 850. So another negative, but even larger. So again, I would say this is 0 and this is negative 360. So I know the full rotation gets me to negative 360. I'm going to have to go past that though. If I do another full rotation, what is that? 720. So how much past that do I need to go to get to 850? $850 minus 720. What's the difference? 130. So I need to go 130 degrees more. So remember, a quadrant is 90. Okay, so 130 is going to be like here-ish. Okay, I made my spiral a little tight. It's hard to see how many times I went around. So I'm going to do that again. So I went 1, 2, and then here into quadrant 3. So now this time though, it's not how far past the full rotation I went, because y'all told me I went an extra 130. That's not my reference angle because I'm closer to the negative side of the x-axis than I am the positive side, right? So my reference angle is actually over here this time. And what would that measure be? How did you get that? Okay, so you could do it that way. The other thing to remember is, remember this we said was negative 90 and negative 180. And y'all told me this extra piece that I went past the second full rotation was 130. So the difference from 130 to 180 is 50. So you could have also done it that way. Good? All right. Back to going in the positive direction. So this is back to being my 90, 180, 270, 360. Let's see how many times we're going to have to go, how many rotations to get to 1310. So I do one full rotation, that's 360, 720. What's another rotation? 1080. So 1080 is where I'm at now, and I have to get to 1310. How much further do I have to go? What's 1310 minus 1080? To what? 230. So what quadrant is that going to put me in? Okay, so I went an extra 230 degrees is what y'all told me. So this right here is what I need to figure out. If that was 230 and this is 180, what's the difference from 180 to 230? That's 50 degrees again, right? What does that tell you about negative 850 and positive 1310? What are those? Those are coterminal angles. Mind blown, right? Okay. Y'all feel okay about finding reference angles, sketching angles in standard position? All right, so this last section, we are just going to give the sign, S-I-G-N, the positive or negative sign of each of those from the previous example. So 380, negative 415, negative 850, and 1310. So we need to remember, what's that mnemonic? What's that memory trick for how to know which trig functions are positive in each quadrant? All students take calculus. All of them are positive in one: sine, tangent, cosine. Okay, so For example A, we said that terminal side ended back up in quadrant 1. So 380, this is in quadrant 1. So that means that all of these should be what? Positive. I'm just going to put a plus or a minus. You can write positive or negative if you prefer. I'm just going to use the symbols. Okay. So then on B, negative 415 ended up in quadrant 4. So in quadrant 4, what's the sine trig function? Negative. And cosine? And tangent? Good. Because quadrant 4 is the C. That's where cosine is positive. All the others are negative. Okay, and then in part C, I ended up in quadrant 3, also in part D. So both of these, I can go ahead and do at the same time. They both ended up in quadrant 3. So what should be positive in quadrant 3? Yeah, tangent's positive. So what about the others? They're negative. Okay, so quadrant 1, they were all positive. Quadrant 4, only cosine, and quadrant 3, only tangent. Y'all feel okay about that? All right. So that's it for coterminal and reference angle notes. You can look back at these and the ones from Tuesday to help you with that assignment I passed out to you. And that assignment, like I said, it's not real long. It's practicing sketching, giving reference angle, and a positive and a negative coterminal angle. So doing all of those, and I think there's 4 problems doing that. And then another problem, just practice giving your ratios in terms of X, Y, and R, as well as OA and H. Okay, so that worksheet over this stuff will be due on Monday by the end of class, or actually by the end of the day. I won't know if it's by the end of class because I won't be here. So as long as you get it in by the end of the day Monday.